Once again, I welcome you the lecture series of this microprocessor and microcontrollers. In the previous sessions, nearly of 7 sessions, we are spending on the microprocessor and all to know about the basic structure of each and every component in that one. Okay, now see this. This is the basic structure of the microprocessor 8086. Okay, so now see this. It has ALU, arithmetic and logical units. Arithmetic can perform the addition, subtraction, multiplication, and division operations. Then it has the logical operations, AND operation, OR operation, NOT operation, XOR operation, and so on. It can perform different types of logical operations. We have different types of registers are there: AX, BX, CX, DX, general purpose registers. We have different types of registers. Segment registers are there: code segment register, data segment registers. Okay, then extra segment registers, stack segment registers are there. Then we have different types of pointers and index registers are there. What are the pointers and index registers? So index pointer, stack pointer register, base pointer registers. Okay, so DA register, so on, different types of registers are there. You have one another type of special register are there: flag register. What is a flag register? Flag register is also there. Flag register, a 16-bit flag register is also there in this register cat. So we have timing and control unit is also there. Then in the last class we already completed the memory, nothing but the RAM and ROM. Equally divided the RAM and ROM. So total memory is 1 MB. Nothing but how it is 1 MB, it depends on the number of address lines. How many address lines we have? 20 address lines. 20 address lines. So that's why 2420 is equal to the 2420 is equal to the 1 MB. So this is the 1 MB. So equal divided into the RAM and ROM. So a physical memory. 1 MB physical memory. So for retrieving the storing the information you can divide it the this entire 1 MB memory into some segments. How many segments are there? 16 logical segments are available. Just a minute. Now see this this 1 MB memory. Okay, this 1 MB memory. You can look at this. Okay, see this. You can divide it to the 16 logical segments. 16 logical segments. Okay. So now we are going to discuss now today's pin description, pin diagram. How many pins are the microprocessor? You know that we have 40 pins on. By using these 40 pins, we can connect it the entire this RAM and ROM memory as well as input-output devices. RAM and ROM memory as well as this input-output device. Only we have 40 pins on. So for that one, you can also connect the power also for this 40 pins. Okay, how we can connect it this memory as well as input output devices by using these 40 pins. At the same time, not only this memory and the input output device, we have some another components is also there to connect to this microprocessor 8086 by using only these 40 pins. Okay, how is it possible? How we can you can utilize this by using this? You can see this. Okay, so see this. You know that our microprocessor is a 16-bit microprocessor. You know that okay. Anyway, see this this 40 pins. By using this 40 pins only, you can effectively connect any of the input output devices and memory devices. So you know that microprocessor, our 8086 microprocessor is a 16-bit microprocessor only, nothing but the register sizes that are used in the microprocessor. Please wait, power cut. Just wait for 2 minutes. Okay. See this. What is the microprocessor bit size? A microprocessor bit size is a 16-bit microprocessor. You know that 16-bit microprocessor. So it has only 40 pins. It has only 40 pins. So now see this. Now see this. Out of these 40 pins only, you are able to connect this so many devices. Input output devices, memory devices, power, then clock and all. Then how we'll able to connect this one? So we can increases the performance of the microprocessor and all. So the entire microprocessor, some pins is divided into the two category of the pins. So nothing but this microprocessor is operating two modes here. Two modes here. So minimum mode as well as the maximum mode to increase the performance of the microprocessor. At the same time, to use these 40 pins in very efficient way. So we can operate this microprocessor in two different ways: minimum mode as well as maximum mode. Minimum mode as well as maximum. So out of this 40 pins only you can use by both of these modes, minimum as well as maximum. How we can use this one? So for our simplicity purpose, we are dividing these 40 pins into three common groups, three different category of the pins. So these 40 pins. So first one is the common signals or common pins. Common pins. We are using both minimum and maximum modes. First category is so the pins, the common pins which are using both minimum and maximum modes. At the same time, next one, next category of the pins is special pins. Special pins can use only for minimum mode. At the same time, the pins that are used only in the maximum. Okay, okay. So for efficient utility of utilization of the pins and all to increase the performance of the microprocessor. Okay, so we can divide the number of pins or we can operate at this microprocessor in two different modes, minimum mode as well as the maximum. So out of these 40 pins, we are using both the modes. So where, how we can utilize the 40 pins into two different modes? That we can simply divide into the three categories. Common mode of the signals in minimum and maximum mode, special signals in minimum mode as well as special signals in maximum. Okay, now see this maximum as well as minimum mode like this, maximum as well as the minimum mode like this, maximum as well as the minimum modes are like this. This is the maximum mode as well as this is the minimum mode. This is the maximum mode signals. These are the some of the minimum mode signals. Maximum mode as well as the minimum mode signals. How we can utilize these signals and we will see this. Okay, the first one you can also okay. The first one we can consider it as the you can see this common signals. As you know that we can the entire signals 40 signals we are divided into the three different categories. First one is common signals used in both minimum and maximum mode. Then only signals used in the minimum mode. Then only signals used in the maximum mode. These are the three different categories. Now first of all you can see this the signals, the common signals that are used in both minimum as well as the maximum. Okay, these are the highlighted. Now see this diagram, some highlighted diagrams. These are first of all you can consider the signals AD 0 to the 15. Nothing but total 16 pins here. We are using here. Total how many pins here? 16. AD 0 to the 15. AD 0 is also considered as a number, but we count 0 to the 15. We have the 16 pins. So AD means here A stands for address and D stands for data. D stands for data. A stands for address. D stands for data. Data. Whenever you send any information to the microprocessor, we are using the address. Nothing but so here you know that memory is like this. memory is segmented like this in addresses. So in each and every address we have the some data, some data, some data. These are the address 001, 1002, 1003, 1004, 1005 is the addresses. Okay, for suppose these are the addresses. For suppose, okay, these addresses we have some data. These address locations we have some data. So how to identify these addresses? These addresses are identified the address lines. These addresses are connected with address lines. How we can consider take this data? This data is taken by the data lines. So this 20 bits lines as address and data lines. So address lines are used to identify the addresses in that memory. The data lines are used to carry the data from the memory to the microprocessor, at the same time CPU to the memory, or from memory to the CPU data lines. So these data lines are bidirectional. Remember, these data lines are bidirectional, but address lines are only unidirectional. Address lines are unidirectional, but these data lines are bidirectional. Nothing but you can send the information from CPU to the memory at the same time for the same lines you are using to get the data from memory to the CPU. But address lines are unidirectional. That means only you can send the information from CPU to the memory only, and unidirectional. Only it can only works in the one direction only. So at the same time, this address and data lines are also used for the you can get the information from the input output devices at the same time. So these are the address lines. Same address lines are placed for the input output devices unidirectional. The same data lines are used for the input output devices. These data lines are always bidirectional. So and I can use the arrow in both sides. That means the bidirectional. Bidirectional. But you can send the information from the same lines at the same time you can receive the information from the same lines. But address, who can generate the address? Who can give the address? The microprocessor is giving the address to this input output devices at the same time to these memories. So these are the only unidirectional lines. So nothing but it can only transfer the information from the CPU to the memory only. So, but data lines are bidirectional. But we can send the information to the microprocessor at the same time to get the information from the CPU to the memory. So bidirectional lines. Okay, that's why. So now for better utilization of this party pins, party pins. Now see this party is the last one. For proper utilization of this party pins, the same pins, you can use it as a multiple purposes. That you can call it as a multiplexed lines. Multiplexed lines. There is difference between bidirectional as well as a multiplex. Bidirectional means here the same lines we can use it to send the information at the same time. The same lines we have to use it to receive the information. That is the bidirectional. This is the bidirectional. But multiplex means here the same pins. Now see this the highlighted ones. AD0 to the AD14. Now you can see this the highlighted area AD0 to the AD0 to the 15. You can see this highlighted area AD0 to the AD4, nothing but the pin number 2 to the pin number 16 at the same time. Pin number 39 to the pin number 35. You can see this AD15 to the AD19. AD0 to the AD0 to the see this AD19. Okay, you can see this, or you can also see this by mistake here. These are the not the AD16. This is only A16. Sorry, this one it has only A16 on. This is not the A16. AD19, sorry. This one only AD15 is there. This is only the A16. A16 only there. I hope that all the diagrams I am using that one, but you can correct that one. It is not the AD16 lines. These are only the A15 up to the A15 is available. So this is not available A16 because the address lines that are available is 20, but data lines is only of 16-bit data lines only. That's why in the segmented memory, you know that in the segmented memory, yes, in the segmented memory, now you know that in the segmented memory, it is 20-bit address lines 20-bit address lines. Out of this 20 bits, uh, so each and every segment is 64 KB. So nothing but 2 power 16 is equal to 64. So what is this 16? The 16 will indicates the data. Nothing but offset address. Offset address is 16-bit addresses. Nothing but that 16 bits is indicates the 16 data lines. You know that one bit is equal to the one pin. One bit is equal to the one pin. One bit is equal to the one pin. So in this diagram I mistaken here. So we have the data lines only D0 to the D15 only. What is address lines? A0 to the A19 are the address lines. Remember, A0 is also considered number 20 address lines. 20 address lines. But here how many data lines are there? 16 data lines are there. Only 16 data lines are there. So what are that number? You can see this highlighted area. So AD 0 to the 14, AD 15. So A16, A17, A18, A19. Okay. At the same time, you see this A stands for address, D stands for data. So nothing but so the same pins, nothing but pin number 2, 3, pin number 2 to 16. The same pins is used for both address as well as data. At the same time, you can see this pin number 38, 37, 36, and 35. The same pins is used for the address as well as S3, S4, S5, S6 is nothing but the status. It can shows the status of the microprocessor, status of the which operation microprocessor is currently doing. So that information is shown by using this status line. You see this A16 slash S3, A17 slash S4, A18 slash S5, A19 slash S6. The same pin numbers 38, 37, 36, and 35 used for the multi-purposes. So that's why these pins, we can call it as a multiplex lines. But you can observe this party, you cannot call it as a multiplex line because this is used only for one purpose only. The same pins is used for the multiple purposes. That time you can call it as a multiplex lines. Now pin number 1 is a not a multiplex line. Now pin number 17 is not a multiplex line. Pin number 18 is not a multiplex line. Pin number 19 is not a multiplex line. Pin number 20 is not a multiplex line. But you can see this pin number 34, 33. At the same time, pin number 28 is used it as a multiplex lines. Remember the same pins we can use it as a multiplex line. So in 8086 microprocessor we have 40 pins. Out of that 40 pins, at 20 pins we can use it as a address lines, address pins. What are the numbers? A0 to the A19. Then again 16 pins we can use it as a data pins. What are the data pins? D0 to the D15. But here there is one small logic here. For both addresses and data, you can utilize it as a same number of pins. For addresses and data, you can utilize as a same number of pins because to reduce us the pin number of pins. But suppose you can separately use addresses as well as data for this one. You can require 36 pins out of 40. For the only data and address purpose, we can utilize it as a 36 pin. So to utilize the 40 pins in more number of ways, okay. For that purpose, what they can consider here, what they can how they can design here for the same pins. It can use it as a both addresses as well as data. Then when it is used, then how we can separate it address as well as data. When it is sent the info address, see this, see this, see this address as well as data, same lines we are using. When address means here, so these are the memory. It has the address. It has address for suppose 1, 2, 3, 4, 5. This has the data. The same lines. This same lines are used for both the address as well as data. Same lines. These are the lines. Same lines are used for both address and data. When it will be worked as address, when it will be worked as data. You know that address is a unidirectional. It can only send the information from CPU to the memory. But data is a bidirectional. But you can send the information at the same time you can receive the information by using this same 20 lines. Out of the 20 lines, so 16 lines are utilized for this, 16 lines are pins are utilized for the data. So our question is, when that 20 lines is act as a data lines, when that 20 lines act as a address lines. So remember one thing here. Remember one thing carefully. This 20 lines is always in address mode. Remember, this 20 lines is always in address mode. Whenever microprocessors want to get the information from the memory to the CPU, or whenever microprocessors want to send the information from CPU to the memory, on the time microprocessor is enable this one, this pin ALE, address latch enable. So on the time that address lines is converted into the data lines. Remember, in minimum mode, in maximum mode, so it can on the QS0. Okay, remember one thing, microprocessor is connected to this memory by using this 20 address and data lines. So these are always in address mode. These lines are always in address mode. Whenever microprocessor is want to take the information from that memory, or it want to send the information to the memory, on that time this address lines is converted into microprocessor is convert these address lines into the data lines. How it is converted? By enabling the by on the address latch enable in minimum mode, or in maximum mode it can use the QS0. It can, by microprocessor is on in that one. Okay, so now that address lines is converted into the data. Okay, okay, these are the lines utilized for the AD0 to the AD50 lines. Remember, address we have the 20-bit address. How many data lines are there? We have only the 16 data lines are there. Because why? Because the memory that is stored in that segments is only of a 16-bit address only, 16-bit data only. That's why we require this 16 address lines, 16 data lines only. Okay, okay. What about this remaining lines? Nothing but A19 to the this line A16, A17, A18, A19, A16/S3, A17/S4, A18/S4, A19/S6. What are the remaining numbers? So nothing but A16 to 19 remaining of 4, 16, 17, 18, 19, 4 pins using for the again address, because our address lines A0 to the A90. So this 4 also consider this one 20 bits. So When these pins will work as address, when these pins will work as a status lines. So status bits, what are the status bits? We have four status bits: S3, S4, S5, S6. We have four status bits are there. Out of that four status bits, S6 logic always 0. Okay, S5 indicates the condition of the interrupt flag. We have the interrupt flag, I flag is there. Then S4 and S3 indicates the which segment register is presently being used in the memory, or which are nothing but CPU is accessing which memory segmented data. This S4 and S3 signals will indicate that CPU is accessing which memory segmented data. Then S6 is always logic 0. S5 will indicate the so whether that interrupt flag, what is the interrupt flag condition? That whether that interrupt flag is on or off, nothing but it is set or reset. First of all, these are also multiplex lines. A19 A19 S6 are sorry, you can see this A19 S6, A18 S5, and so on. A17 S3, S4, A16 S3. When this signals A9 address signals is converted into the status net, but these are also, you know that always these pins are in address modes. A means in address modes. When these pins is converted into the status, you know that one logic is there. So this address lines is converted into the data lines by using which pin address latch enable or QS0. So whenever this address latch enable is on that time, this address lines is converted into the status lines also here. Okay. Now see this this S3 and S4 will indicate what is the meaning of this. S3 and S4 will indicate that whether the CPU is accessing which segmented memory, whether code segmented or data segmented or extra segmented or otherwise stack segment. Whether you know that when this S3 S4 pins are 0 0 0 indicates the alternate data, is this 0 and 1 will access microprocessor access the stack data, whether it is 1 0 will access the code data, whether it is 1 1 will access the extra segment or data. Okay. For that same for the same for the common signal, we have the another type of signal BHE bar and S. Bus high enable and status. Remember BHE means here bus high enable. Remember BHE, the full form is bus high enable. As well as next one of the signal status signal is also there, S7. S7 is also there. What is the meaning of this bus high enable? Bus high enable, that meaning is, you know that data is a 16 bit. Data is a 16 bit. So this out of this 16 bit, we are dividing into the 8 bits. 8 bits. Nothing but lower order 8 bits, higher order 8 bits. Data 16. Out of this 16 bit data, you are converting into the lower order 8 bits as well as the higher order 8 bits data. Lower order 8 bits as well as the higher order 8 bits. Okay, whenever this this data and all is responsible for AX, BX, CX and DX. You know that AX is replaced as AHAL, BH, BL. Okay, CX we can use it as a CHCL, DX we can use it as a DX, DH and DL. What is DH, DL, AHL? H stands for higher order, L stands for lower order. Whenever our data is only of 8-bit data, we can use it as a AHRA on that time. So out of these 16 bits, only 8 bits are used here. What is this bus I enable? So one thing I will remember one thing here, ph bar. Bar, whenever any signal is represents this bar, this signal, this bar signal, that indicates the a negative logic. You know that in STLD or some other subject, we are very much known that one. A bar will indicates the negative logic. Negative logic means here zero is nothing but on, one is nothing but off. A negative logic. Nothing but BHE bar is equal to zero, nothing but on. BHE bar is equal to one is nothing but off. A bar will indicates the negative. You know that in generally one is nothing but on, zero is nothing but off in general. But in negative logic is quite different. It is quite opposite. Nothing but zero is on, one is off. So whether that BHE bar is equal to zero, nothing but on. It is on, nothing but it is enabled. So on the time, so out of that 15 bit, 16 bit data lines, only this higher order 8 bits, nothing but D8 to the D15 lines are worked. Okay, so another time it will work as a S7. Okay, as I said, microprocessor is worked in two different modes, nothing but maximum minimum. How it is worked as a maximum mode? When mn bar is equal to 1 on the time, so mn is equal to 1 on the time. Yes, so when mn is equal to 1 on the time, it will work as a minimum mode. When mn is equal, mx is equal to 0 on that time, it will work as a maximum mode. Okay. Okay, so these are the some signals. So the signal BHE and S7 as well as M and X. M and nothing but microprocessor is working two different modes, maximum mode as well as the minimum mode. So when it is worked as a minimum mode, nothing but Mn is equal to 1, nothing but set. Then Mx bar is equal to 0 is nothing but will work as a maximum. So next signal is the read bar, RD bar. RD bar is nothing but it is equal to 0 read. Is equal to 0 is nothing but the read. As I said, when any signal it has a bar, nothing but it will work as a negative logic, nothing but 0 is on, 1 is off. So when this read signal is used, when it will be used read signal. Some we have some another signals also there. Hold acknowledgement, read and write. You are combiningly known the read and write signals and all. So maybe we will discuss it in the next class. Okay. Okay. Thank you. Thank you.